Welcome back to Statics. Want to talk today about position vectors. Position vector describes the relative location of a point B relative to some other point A, for example. So let me first of all, again, position vectors, what we're going to talk about. And I'll start off just by drawing a kind of example. In the first case, we'll have our point A location will be the origin. So we're going to draw a vector from the origin. Here we have our x coordinates, our y coordinates, and we have some position location or point A, which has coordinates ax, comma ay, ax, ay, and it could have az coordinates as well, but we're just going to keep it in the xy plane for now. So the position vector here would be, I'll put it up here. And typically we use the letter lowercase r in the textbook, and I'll write r sub a. So it's indicating that it's going from the origin to point A. It is a vector, so we draw an arrow on top, and it's just going to be ax times I plus ay times j. Okay, so it's just the distance in the x direction times our unit vector in the x direction plus the distance in the y direction, a sub y, times our unit vector in the j direction. Now you can also define this for a general case where we have our 2 points, one of which is not at the origin. So I'll locate a point here, A. Coordinates are ax, ay. And we'll have a second point over here, which we'll call B, with coordinates bx, comma by. And we're going to draw a vector between them. Let's see if I can make it. Oh, I missed. I'm going to relocate B to here. Here's my A. And if I want to write my position vector from A to B, it'll be R, again, vector equals bx minus ax. So it's the distance, essentially the travel distance in the x direction from A to B. So it's where you're going to minus where you're going from, coming from, times I plus by minus ay times j. And we make sure you put arrows above those. And obviously this is also transferable to the third dimension. So if we had an AZ and a BZ value, then I would just add another term on here, and it would be BZ minus AZ times K, unit vector in the Z direction. Now, if for some reason, and you are going to find reasons to do this, you want a unit vector in this direction, and I'll call that UAB. So we want a unit vector in the direction of our position vector. This is a unit vector. And we know that unit vectors have a magnitude of 1. So how do we go from a position vector, which goes from has a magnitude that's not 1 to one that has 1? All we're going to do is we divide our vector, this vector, by the magnitude of the vector itself. And so we know, so what we can write here is that UAB would be equal, UAB is a unit vector, so we put an arrow on top, would equal RAB times the magnitude of that position vector. And I'll just write it as a scalar form. So this is the magnitude of RAB, and we know that we can find RAB using the Pythagorean theorem, and we just write that RAB equals the square root, and I'm going to run out of room here, but bx minus ax squared plus by minus ay squared, and I'll put it down here. This is all within the square root, bz minus az squared. Okay, and then in order to do this division, to carry this out, you're going to take this RAB term and you're going to divide each one of these in term. And I'll just write that at the bottom, so we'll have it So you're going to write U, A, B. Again, here's our unit vector in the direction from A to B equals BX minus AX over this thing, the magnitude of our position vector RAB times I plus BY minus AY over RAB times J. Again, unit vector in the y direction. And then we're going to have one more term, which is BZ minus AZ divided by RAB times our unit vector in the k direction. All right, so that's it. So we have what we talked about are position vectors. We gave the general case or specific case of a position vector starting at the origin. Then we talked about a position vector starting from arbitrary point A to an arbitrary point B. And we came up with this result. And then we talked about unit vectors in the direction of a position vector. And we basically said that that unit vector is the position vector divided by the magnitude of the position vector. We showed the Pythagorean theorem for finding the magnitude of the position vectors, the magnitude. And lastly, we wrote the result, how we actually would find that position unit vector in the direction from A to B. And that's all I want to talk about today. So the next thing we're going to talk about are forces along a particular line. And you are going to be using this concept of position vectors and unit vectors, which is why we introduced it at this time. So send me any questions, and I'll see you in class.